Section 5, solving square root and other radical equations. So now we've finished working with exponents. Theoretically, we know all the properties of exponents, and we know how they look and how to work with them. And now we're going to get into equations and how to solve equations with radicals. So a radical equation is any equation that has a variable under the radical. To solve them, isolate the radical. So like step 1 right there. Isolate the radical, then raise both sides of the equation to the power needed to remove the radical. So if you're square rooting something, then you're raising both sides to the second power. When you raise both sides of an equation to a power, you introduce extra solutions. Extraneous means like extra. Extraneous limbs would be limbs that you don't normally have that you shouldn't have. So extraneous solutions are solutions that you shouldn't normally get, but you did get. That's why we must, if I had time, I'd circle this 141 times, because you must check your answers to be sure that your answers work. You are going to get answers that don't work in this section. You have to check your answers. If you don't, then you will get wrong answers. And if you give me wrong answers because you didn't check your answers, then you are wrong. Okay, solve the equation. The first thing we want to do is isolate the radicals. So get that thing by itself. In order to do that, I got to get rid of this 3 that's hanging out front. So subtract 3 from both sides. And now I have the square root of 2x minus 3 equals 5. Now that the square root is by itself, I can get rid of the square root. How am I going to get rid of the square root? So I'm not multiplying by an exponent. I'm raising both sides to the second power, because the square root of something goes away if I square it. But I have to square both sides in order to do that. So I have the square root of something that's being squared. What happens to the square root and the square? They go away, and I'm left with 2x minus 3 equals 25. And now we're right back into chapter 1 of Algebra 1. What do? Add 3 to both sides, so that gives me 2x equals 28. And now x equals 14. There's my answer. But what do I have to do? Did I take the square root of both sides of an equation? And I don't use plus or minus. I have to check. I must check. It doesn't take that long to do. Take the 14, plug it back into the original equation. It has to go all the way back to the original. So I take 14 and I plug it in. 2 times 14 is 28, minus 3 is 25. The square root of 25 is 5 plus 3 is, so we got the correct answer. What should I do on the next one? Shh. I know we're all happy, but we add 5 to both sides, and what do we get? Now what? We isolated the square root, so we square both sides since it's a square root. If it was a cube root, what would we do? Probably, yeah. Okay, what do we get? Okay, now what? All right, let's say I did, so I got 4x equals. All right, so therefore, six. Now what? Check. You have to check. What do we get? 24 plus 1 is, square root is, minus 5 is, so this worked. Don't circle your answer until you know that it worked. If this didn't work when I plug it back in, then it would not work and there'd be no solution. Or you made a mistake. Yeah, that's possible. Okay. That was like the easy introduction. To solve equations of the form x to the m over n, so rational exponent equals some constant, raise each side to the power. What happened to the power? It's a reciprocal. So raise each side to the reciprocal power. Because when you raise powers to powers, you multiply. And if I multiply m over n times n over m, what do I get? 1. And I'd be left with x to the first power. So if either m or n is even, this is the monkey wrench that is thrown into this. This is actually not difficult, but you have to remember this property right here. If either the numerator or the denominator is even, so like a 2 or a 4 or whatever, then include the absolute value symbols. So solve this equation. What should we do? Divide by 3. Good. I can't distribute the 3 in because of this exponent sitting right here. But I can divide both sides by 3. And that gives me x plus 1 to the 2/3 power equals 4. So now I want to get rid of the 2/3 power so that I can solve for x. In order to get rid of the 2/3 power, I'm going to raise both sides to the what? The reciprocal power, which is the 3/2 power. Hold on. Once I do that, I have a power to a power here. 2/3 times 3/2 is 1. So I'm left with x plus 1. Now I have 4 to the 3/2 power, and last time we learned that we could handle this either by raising 4 to the 3rd power and then taking the square root, or take the square root first and then raise to the 3rd power. Square root first. Square root of 4 is 2 to the 3rd is, so we get 8. Subtract 1 from both sides and we get x equals 7. So should we check our answer here? Yes, we should. Take 7 and plug it in. 7 plus 1 is 8 to the 2/3 power. Cube root of 8 squared, or, yeah, it's 4. 8 squared, cube root. Either way, you get 4. 4 times 3 is, so we did get 12, which means x equals 7 is our answer. So what should we do on this one? If you can do this one, you can do every problem on 11 through 23. If we are solving an equation, we are always trying to isolate the term first, which means we want to get rid of this 1 first. So we're going to subtract 1 from both sides. We're getting this term by itself. Once I do that, then now I have 3 times the 5th root of x plus 1 to the 3rd power equals 24. Now divide by 3. And now we have the 5th root of x plus 1 to the 3rd power equals 8. Now what? Please turn it into a rational exponent. Nth roots are so terrible. This becomes x plus 1 to the 3/5 equals 8. And then we can raise both sides to the 5/3. Thank you for waiting. This becomes x plus 1 equals, the cube root of 8 is 2, 2 to the 5th, 2 times 2, times 2 times 2, times 2, 32, which means x equals 31. And if you were to check that, you would find that that is the correct answer.